Hello. Continuing on with lesson 9.1. This is the second part. We're talking about rationalizing the denominator. Remember in our first part we said cannot have a radical in the denominator, and so to get rid of it, we call that process rationalizing the denominator. So for example, this is, if you're following along, which I hope you are, page 482, and this is example number 4. So if I start with a problem, square root of 5 over square root of 3n, and I need to get rid of that radical in the denominator, we can do it by multiplying it by itself. So I have square root of 3n times the square root of 3n, because that's going to be the square root of 9n squared, two perfect squares, which simplify to just 3n. Remember back in the day, the square root of x times the square root of x is the square root of x squared, and that's just x. And that numerator, remember, whatever you do to the denominator, you must also do to the numerator. That means that we're not changing the value, because essentially we're just multiplying by 1, which just changed it to, so we can change its form and get rid of that radical in the denominator. And so when we multiply the numerator, square root of 15n over a denominator of 3n, no radical in the denominator, and that was our goal. The second part of that example was 2 over the cube root of 9. Now, remember here we wanted to make this a perfect square, and so we could just multiply it by itself. If it's a cube root, or a higher order root, I need it to be a perfect, in this case, cube root. So 9 times what would make a perfect cube? 9 times 3 would be 27. That would make that denominator a perfect cube, and so that's what we're going to multiply this by, the cube root of 3. And whatever we're doing to that denominator, we're also doing to the numerator. When we finish, or on the way, we have 2 times the cube root of 3. Nothing else we can do with that numerator. In the denominator, I now have the cube root of 27. And we know that the cube root of 27 is just 3. 2/3 doesn't reduce, and so my final answer is 2 times the cube root of 3 all over 3. And then, if we have a radical expression that contains a sum or a difference in the denominator, then we multiply by something called a conjugate. A conjugate, if I start with a plus b, my conjugate is going to be a minus b. That first number stays the same, the second number or the expression stays the same. The only thing that's different is the sign that joins them. So if I start with positive, a plus, it's going to be a minus. If I had started with a minus, the conjugate would be a plus. Everything's the same, they just have opposite signs. In your book, they showed you a times the square root of b plus c times the square root of d. Its conjugate would be a square root of b minus c square root of d. The reason we do this is to get rid of that middle term so that when we finish, we don't have a radical in the denominator. So if we FOIL these, how would that work? I have a squared times the square root of b squared, which is just going to be b, plus I have a, well actually in this case, minus. So that was the first term. I'm taking this times that second term, and so that would be minus ac times the square root of bd. Now I'm working with this middle term, and that would be positive ac times the square root of bd, if I put them in the same order, minus c squared, and the square root of d times the square root of d is just square root of d squared, or d. Notice that those middle terms disappear, and you're left with a squared times b minus c squared times d. No radical. If this were in the denominator, that's when we do that, to get rid of that radical in the denominator. It's called multiplying by the conjugate. So what does that look like when we actually do it? Look at example 5. It's the one sort of in the middle of that page. So we were given 7 over a denominator of 2 minus. It's a difference. It's got a radical down there. So that's your clue. You're going to multiply by the conjugate. The conjugate is going to be 2, because that was 2, plus, because I'm going to have the opposite sign, and then square root of 3, because that's what I started with. And whatever you do to the denominator, you're also doing to the numerator. So I'm going to multiply that numerator by 2 plus the square root of 3. And then we're going to do it. So 7 times 2 is 14, plus 7 root 3, all over. I do not have to FOIL these if you remember the pattern that we just talked about. I'm squaring that first term, so that's 4. I'm squaring the second term, it's always going to be minus. Squaring the second term, so square root of 9 is just going to be 3. Middle term, we know because of the pattern, it's not going to be there. And so when I finish, 4 minus 3 is 1. I'm just going to have 14 plus 7 root 3. Look at example B. Denominator is the square root of 3 plus 1. Again, I've got a sum. I'm going to multiply by the conjugate. The conjugate is going to be the square root of 3 minus 1. Whatever you do to the denominator, you're doing to the numerator. So that's square root of 3 minus 1 again. And multiply. So 4 root 3 minus 4 over denominator of square root of 3 times the square root of 3 is 3 minus 1. So this is going to be 2. And I'm going to have 4 root 3 minus 4 over 2. I've got to simplify. So if I factored out a 4 or a 2, 4, that looks better. Square root of 3 minus 1 over 2. I'm reducing, so I have 2. So 2 root 3 minus 2 would be my final answer after I simplify. Do not cancel up here. You must factor before you can cancel. This is really 4 root 3 over 2. That's a common denominator, minus 4 over 2. So if you don't like to factor and then cancel, you can write them over the common denominator and cancel each part and end up with 2 root 3 minus 2, just like we did when we factored and canceled. The main thing is, these don't cancel. I hope nobody makes that mistake. So then, look at example, are we monitoring progress? Monitoring progress. So look on page 402, down at the bottom, there are a whole, 482, sorry. There are a whole bunch of problems to look at. You could pause here and check, or you can stick with me and we'll just do them together. I can't even force the pause. I'm going to try. I don't even know that it matters really. So, monitoring progress. Looking at number 1. It was 1 over the square root of 5. I'm multiplying by, it's a square root. I want that to be a perfect square. Square root of 5 over 5 over the square root of 5. And when I finish, my answer is the square root of 5 over 5. If I'm looking at, that was 13. If I'm looking at 14, that was the square root of 10 divided by the square root of 3. Cannot have that radical in the denominator. I need to make it a perfect square, so I'm going to multiply by the square root of 3. That means I'm multiplying that numerator by the square root of 3. And I have the square root of 30 over 3. 30 is 6 times 5, 2 times 3 times 5, so no perfect square factor. And so I leave my answer just like that. If I'm looking at number 15, that was 7 over the square root of 28. I'm sorry. That was 7 over the square root of 2x. Helps if I can read my own writing. Times the square root of 2x over the square root of 2x, because we don't want a radical in our denominator. So when we finish, we have 7 root 2x over denominator of 2x. Notice that these don't cancel either. This one is under the radical. It can only work with other things that are under the radical. If I'm looking at number 16, that one was the square root of 2y squared divided by 3. And so I'm going to pull it apart. Nothing I can do with it like that. So I have the square root of 2y squared, and it's the square root of 3 in the denominator. Got to get rid of the radical in the denominator, so you're going to multiply both numerator and denominator by that square root of 3. And when you do that, you're going to have that. You're going to have 3 in the denominator. And in the numerator, I could have simplified this before I started, or simplify it now, and I have y times the square root of 6. That was number 16. If I'm looking at 17, I need to see how much can fit in the screen. But I'm looking at 17. That was 5 divided by the cube root of 32. Well, the cube root of 32. What do I need? Because it's cube root. So I don't want to multiply by another cube root of 32 because that might not be a perfect cube either. So what is 32? I could think of that as well, lots of things really. But if I made it 64, how can I best show you to get there? Cube root. I'm thinking of perfect cubes. That's the best way. So 32 times what? So I need to multiply this by the cube root of 2, because then I would have the cube root of 64. It has to be a perfect cube. I want the smallest perfect cube I can think of. So if I'm starting with 32, 32 times 2 is 64, and the cube root of 64 is 4. And so I multiply this by the cube root of 2. And when I finish, I have 5 times the cube root of 2, because that's what we multiplied by. And down here, I have the cube root of 64, which is 4. Number 18, what do I have for that? Number 18 was 8 over 1 plus the square root of 3. The minute you see a sum or a difference in the denominator with a radical, you're thinking multiplying by the conjugate. And so the conjugate for this is going to be 1 minus root 3. Whatever you do to that denominator, you're doing to the numerator, so you're multiplying it by 1 minus root 3. And then just distributing or multiplying, so I have 8 minus 8 root 3 over 1. I'm squaring these. I know this is subtracting. I'm squaring square root of 3 times square root of 3, square root of 9, so 3. And 1 minus 3 is going to be negative 2. And up here I have 8 minus 8 root 3. I still in them covering it up though. And I need to factor. So if I pull out that 4, I would have 2 minus 2 root 3, all divided by 2. That cancels. And so I have 4 minus 4 root 3. I don't know the best way to do that, but I know it'd actually be minus 4 plus 4 root 3. If I'm finishing up, don't lose your minus sign like I just did when I'm talking to you on the board. Keep that minus sign, keep that minus sign. When I cancel, that's a negative 1 out in front. And so that was 2. Negative 2 times 2 is the negative 4, and negative 2 times the negative 2 was the positive 4. That was number 18. Look at number 19. Another conjugate one like that. So I have the square root of 13. This is for number 19. We have the square root of 13, and it's over the square root of 5 minus the square root of 2. So this time, no, it's not. Just minus 2. Nothing fancy. Conjugate for that is going to be, right, square root of 5 plus 2, square root of 5 plus 2, and we're going to multiply. So in that numerator, I have the square root of 5 times 13, which is 65, and 2 times the square root of 13 was my numerator. In the denominator, we're squaring that first term, so that's going to be 5. It's going to be subtracting, and we're minus squaring the second term, so 2 times 2 is 4. So this is over 1. I'm going to have the square root of 65 minus 2 root 13 for my final answer. It doesn't simplify any further. And the last one of these, for number 20, was 12 over the square root of 2 plus the square root of 7. Doesn't matter that they're two radicals, it's still the conjugate. So the first term is square root of 2, it stays the same. That's the sign that becomes the opposite. So instead of adding, we're going to subtract, and it's still square root of 7. I'm still multiplying that numerator by that same thing. And then when we do that, we have 12 times root 2 minus root 7. I'm squaring these, so 2 minus, because the positive and the negative is always minus, and 7, 2 minus 7 is going to be negative 5. Nothing reduces. I can leave it like that, or I can distribute and have negative 12 root 2 minus 12 root 7 all over 5. Make sure you get that negative sign. And then look at example 6. It's one of our favorite word problems. The only difference is it's got radicals in it. the process is still the same. You're going to read it carefully. If it gives you a formula, you're going to read the formula and make sure you understand what the variables are representing. So in your book, at the top of page 483, look and see what they have. The distance d in miles that you can see to the horizon with your eye level h feet above the water is given by, they give you the formula. D, that's the distance that you can see, was the square root of 3 times the height that you are above the water divided by 2. How far can you see when your eye level is 5 feet above the water? Well, where does the 5 go? That was the height. So all we have is the D that we're looking for is the square root of 3 times 5 divided by 2. That's the square root of 15 divided by the square root of 2. And if I put that in my calculator, we'll get rid of this denominator. I would like you to do, your calculator would do this for you, but while we're in school, we're going to do it. My whole idea is to practice getting rid of that denominator, and so that's what I want to see on your paper. Multiply by the square root of 2, so I have the square root of 30 divided by the square root of 2 times the square root of 2 is just 2. And at that point, you can put it in your calculator, and out would come an approximation of 2.74 miles. So what we did was we read the problem, and they gave us a formula. We made sure we knew what the variables represented, so we knew which one to replace with the value that they gave us. And then it was just a simple algebra problem. We just multiplied, we pulled them apart, we got rid of the radical in the denominator, and found the approximation. So that was number 6, not too bad. Number 7, not too bad either. If you probably have heard Mr. Zeiser, or maybe even in history class, talk about the Golden Triangle, because the Greeks had beautiful architecture. That Parthenon is world famous for generations. And there was a golden ratio, length to width, the Greeks said. Length to width is perfect if it was 1 plus the square root of 5 to 2. Where I've got a length of 1 plus root 5 and a width of 2. And so anytime I've got a ratio, I'm thinking proportions, most likely. And so in example 7, they define the golden rectangle, 1 plus square root of 5 to 2. And the dimension on the face of the Parthenon forms a golden triangle. So what was the height if the length was 31 meters? Well, to solve it, we're going to build that ratio. So I have 1 plus the square root of 5 is to 2. As, remember, this is the length and this is the width or height. This is what we're looking for. So put that as your variable. And then if you go back and look at the picture, its length was 31 meters. So now we have a proportion. How do we solve proportions? Cross multiply. So I have h plus h root 5. Well, let's just leave it. H times 1 plus root 5 equals 2 times 31, or 62. I'm going to find h by dividing by that number that we multiplied by. So h is going to be equal to 62 times 1 plus the square root of 5. Do I have a radical down there? And it's a sum, so we know we're going to take the conjugate. So that's going to be 1 minus root 5. 1 minus root 5. And when we finish that, I'm going to multiply, so I'm going to have 62 times 1 minus root 5 all over. I'm squaring that first one as 1. No, I'm subtracting. 5, square root of 5 times square root of 5 is just 5. So 1 minus 5 makes that denominator a -4. And that means I could reduce. And when I do that, or at this point, you could put it in your calculator, which I think is what your book did. And if you reduce, you can only get rid of the 2, so 31. I don't know if that really helped. So in my calculator, it would be 100, I'm sorry, it would be 19.16 meters. 19.16 meters, just about. There are 2 monitoring progress problems down at the bottom of that page, and that, I think, is where we're going to quit for today. So look at those. Where are we? Number 21, I don't know if I worked these out for you. Oh, I did. So number 21, in example 6, how far can you see when your eye level is 35 feet above the water? So I'm going back to number 6 and I'm using that same formula. This is for monitoring progress 21. This time we're 35 feet above, and that formula was the distance equals the square root of 3 times the height divided by 2. This time the height is 35, so the distance is the square root of 3 times 35, which was 105 divided by 2. Doesn't go evenly, so just rationalize that denominator, and I have 210, square root of 210 divided by 2. At that point, I'm going to put it in my calculator and find out that that was about 7.25 miles. So I'm using the formula that they gave me from example 6, replacing h with that new height, and then just getting rid of that denominator, putting it in my calculator, good to go. The last one, number 22, was using that golden rectangle again. So I've got a dance floor this time. The shorter side is 50 feet. What's the length of the longer side? So remember, I've got length to width. The length was 1 plus the square root of 5, and the width was 2 to be in that golden rectangle. And that equals, for my dance floor, this time I know 50 is the length, and I'm looking for the width, which is the height. And so I'm going to cross multiply again. So h times 1 plus root 5 equals 2 times 50, which is 100. I'm solving for h, so we're going to divide by that 1 plus root 5. So when we do that, am I still in? Sort of. H equals 100 divided by 1 plus root 5. At that point, we're going to multiply by the conjugate. That conjugate is 1 minus root 5, 1 minus root 5. I'm multiplying that numerator, so you have 100 times 1 minus root 5 over denominator. Square the first term, you get 1. It's going to subtract 5. So this time it's 1 minus 5 is negative 4 for my denominator, which means I have cancels, negative 25 times 1 minus root 5, or negative 25 plus 25 root 5, and then put that in your calculator and find out that that was approximately 81 feet. I'm going to end this lesson here. We've got one more, and then we'll wrap up this chapter. Homework tonight is the 2 worksheets they'll be labeled 9.1b, worksheets, I think 1 and 2. I'll see you next time, and we'll be through with this one.